complete the rest. So let's pretend here are the zeros. Now, if you guys remember when we were doing the factoring, instead of writing the solution set, we'd always write the zeros or the x-intercepts as x equaled, correct? Do you guys remember that? Instead of writing it as a solution set, I'm seeing some glazy eyes, so I'm not sure what's happening. So y equals x squared minus 7x plus 12. We factored that, right? X minus 3 times x minus 4. Then we set them both equal to 0. Then we solved for x. Does everybody follow me with what we did first example of today? Yes? OK. So what I want you guys to understand is now what I'm doing is we're going to do this problem. We're going to do the exact opposite steps. Instead of doing step 1, step 2, step 3, now we're going to say that's step 1, that's going to be step 2, that's step 3, and that's step 4. So we're just simply working backwards. So step 1, when you're given the zeros, set all of your zeros equal to x. So instead of going down, we're basically going back up. Then step number 2 is set all of your zeros. Now set all of them equal to the number 0. So therefore, I have to get them all to the same side as the x. OK? Now, why am I setting them equal to 0? Because what you guys need to understand is to write the equation on the polynomial, the reason why we went from here to here is by the zero product property. When you have the product of binomials equal to 0, you can set each binomial or each factor equal to 0. Well, if I have all of these equal to 0, that means I can rewrite them as the product equal to 0. Does that make sense? So therefore, I'm just going to go 0 equals x plus 1 times x plus 2 times x minus 2 times x minus 0. Do you guys agree with me? Is just x? OK, so we'll just leave that as x. Now, to go from here to here, well, the reverse of factoring would be multiplying. So now we need to multiply this out. So this kind of goes into number 44, which I'm going to check to make sure you guys did correctly. So if it was x plus 2 cubed, so make sure you guys did that correctly. Now, in this case, you guys can see I have a difference of 2 squares. Does everybody see the difference of 2 squares? See how these terms are exactly the same, but one's positive, one's negative? So in this case, I can cheat a little bit and not have to do FOIL. This is an example of where I only need to multiply my first and last 2 terms, because if you have done enough of these examples, you would remember that the middle terms add to 0 anyways. So I get 0. Actually, again, if we're trying to find 0, the last step would be to replace that with our function or an equation. So I have x plus 1. This multiplies, gives me x squared minus 4 times x. Then I could distribute the x here. So I have f of x equals x plus 1 times x cubed minus 4x. Does everybody follow me? Now, I just need to multiply by using FOIL again. So in this case, I can't multiply the first and last 2 terms because they're not exactly the same. So now I just need to apply FOIL. Or I always like to use the box method because especially when you guys are getting into these binomials that are going to be like a lot of different terms, it sometimes gets very confusing. So rather than using FOIL, I'm going to use the box method, where basically I just take the 2 products, put them on the side of a box, and multiply. X cubed times x is x to the 4th. X cubed times 1 is x cubed. X times negative 4x is negative 4x squared. And 1 times negative 4x is a negative 4x. And you guys can see that none of my terms have the same power. So therefore, I can't combine any of them. My final polynomial is f of x equals x to the 4th plus x cubed minus 4x squared minus 4x. Now, let's check our work. degree is 4, correct? Yes? How many x-intercept solutions should I have? Or 4. How many did I have? I'm good.